Before we get started, I have a couple of problems that I wanted to talk about. But before I do that, I also just want to remind you guys of what's going on this weekend in case you haven't done it yet. So if you click over here to Hawks, you have got to do the lessons for the week is what we've covered. 2.3a, 2.3b, and 2.4. We'll be finishing up 2.4 today. And don't forget, this is all due on Sunday by 11:59 p.m. But your quiz is due on Saturday at 11:59 p.m. Hopefully you've already done it, but this quiz is on previous section 2.3a, which is pretty much your derivative rules. And that's kind of what I want to go over, a couple of derivative problems with you guys before we get into the marginal analysis stuff. So let's come over here and take a look at it. All right, here's a couple of problems. This is a couple of different students send me some questions that they had and wanted me to look at, and they were having some difficulties with some of these guys on plugging them into your Hawks homework system and stuff. So the first one is this. G of x is equal to negative 1/3 x to the 5th plus 3 minus 5 halves x cubed minus 5x to the 4th. And directions very simply say take derivative. Well, remember in calculus, because I am preparing you guys for your next coming test here, labeling is everything. So, you can, what if the function is called g of x, what's its derivative going to be called? G prime of x. You could also write this as dg over dx if you like your Germans and your Leibniz notation. We'll take it either way. Traditionally, we use the Newtonian notation, g prime of x. Now, I think it was because of the fractions that bothered them. So I'm going to take this slowly and actually talk about take the derivative of this guy, and then we'll worry about your fractions. So the function g of x equals negative 1/3 x to the 5th plus 3 minus 5 half x cubed minus 5x to the 4th. When you take derivative of sums and difference, you take derivative of each one. And the first term is negative 1/3 x to the 5th. You hold on to that constant. It holds out front. And the derivative of x to the 5th is times 5x to the 4th. Plus, then you go for the next guy. The derivative of 3, being a constant, is what? 0. Minus 5 halves is a constant. It holds over. What is the derivative of x cubed? Bring down your power, 3x squared, and you multiply. Minus 5 is a constant. It holds over. Derivative of x to the 4th, you bring down your power, 4x, and subtract 1, 3. Now, you've got the answer. You're just going to have to clean it up. And I think this was probably the issue that the student was having here. So therefore, g prime of x is equal to, well, negative 1/3 times 5. You can make anybody a fraction by seeking them over 1. And when you multiply fractions, just multiply the numerator divided by multiply the denominator. So this would be negative 1 times 5, which would be negative 5 over 3 times 1, which is 3. X to the 4th, no reason to write 0, minus, again, this would be 5 halves times 3, or 3 over 1, and 5 times 3 is 15, so that would be 15 halves, x squared, and then another minus, 5 times 4 is 20x cubed. And there's my result. Now, start out with a somewhat easier problem. Again, fractions didn't tend to bother students, but that wasn't too bad. It's the next one that really kills students. Now, first things first. We got this function. F of x equals negative 3x to the 10/3 minus 2x to the 2/3 plus 2 divided by the cube root of x. Well, the first things first. I don't do cube roots. What's a cube root also known as? 1/3 power. So this would be negative 3x to the 10/3 minus 2x to the 2/3 plus 2 divided by x to the 1/3. At this present time, we don't have a quotient rule. We'll get to that later. That's a chapter 3 thing. But if you look at this particular problem, I've got a function divided by a single term in the denominator. Now, this guy is special because you can clean up the algebra. So take this 1/3 and x to the 1/3 and put it under each term in the numerator. basically, you're basically busting up the common denominator here. So you get f of x to be equal to negative 3x to the 10/3 divided by x to the 1/3 minus 2x to the 2/3 divided by x to the 1/3 plus 2 divided by x to the 1/3. Now we're going to clean it up. Well, when you're dividing, what do I get to do with the exponents since they're like bases here? I get to subtract exponents. So the constant would stay there. This would be negative 3x, but 10/3, x to the 10/3 divided by x to the 1/3. Well, 10/3 minus 1/3 is how much? And 9/3 is also known as, so this cleans up actually rather nicely. So it becomes negative x, negative 3x cubed. Minus 2, and here we go. We got x to the 2/3 divided by x to the 1/3. When you divide it, subtract exponents. 2/3 minus 1/3 is 1/3. Plus, now 2 divided by x to the 1/3. I don't like stuff in the denominator either, so I bring them to the numerator, but I got to make the exponent negative. So this becomes 2x to the negative 1/3. Now, take my derivative. Now, again, same idea, classic power rule. Derivative of x to a power, you bring down the power x and subtract 1, and constants hold over, so I can do a lot of this math in my head here. I'm going to go ahead and hold the negative 3 there. Derivative of x cubed is 3x squared, and 3 times that negative 3 makes it negative 9x squared. Do the same thing even with fractions here. I've got negative 2x to the 1/3. Multiply 1/3 by negative 2, that gives you negative 2/3 x. But then you got to subtract 1. What is 1/3 minus 1? Very good, negative 2/3. And then the last one, I've got 2x to the negative 1/3. You bring down your negative 1/3 times the 2. That makes it negative 2/3 x, and you subtract 1. Negative 1/3 minus 1. Negative 1/3 minus 3/3 makes it negative 4/3. And this is your answer. And this is the way you should type it in terms of Hawks. The student, I can tell you when she sent me an email, her problem was she was trying to clean up the answer. And yeah, you can clean up this answer, but she was making some careless errors in that fine fact. In cleaning up this answer, she was trying to write the answer like this. It would have been f prime of x is equal to negative 9x squared minus 2 over 3, because this is a negative exponent goes on the bottom. And when you got a fraction, it becomes the cube root of x squared. And this is minus 2/3. And this x to the negative 4/3, that gives you the same thing as the cube root of x to the 4th. If you want, your negative exponent goes on the bottom. And she was trying to manipulate the problem like this and then trying to type it into Hawk. Why? I know, we're real happy with this. Please, just leave it like this. You can do this if you want to. When we solve for stuff, yeah, you want to do this. But you see where the issue was at, was actually trying to type this thing in and get the cube roots and the x to the, no need for that. And the other issue she was doing was, this was a plus, and then she put the minus out front. She was also doing on Hawks, plus minus. Well, Hawks is going to throw it. That's a computer issue right there. You can't do a plus minus. What is plus a negative also known as? Subtraction. Just leave it subtraction. Don't, combine your little signs there. That was another issue that she was having. And I wonder why Hawks was actually throwing a big fit about all this stuff. Just saying. But this is good. We like this. Just leave it like that. Does that make sense, though? Other questions you guys have before I move on into section 2.4 today? All right. Now, section 2.4 is called Marginal Analysis. All right. So, before we get started, let's talk about everything you've learned up to date here. Well, at least on this concept of derivative. So what I want to talk about here is, pretty much I'm setting you guys up with word problems. Derivative. We just took some derivatives here. But when we started giving you guys word problems, you got to look for certain buzzwords to let you know that you should be taking the derivative of something or other. Now, let's go through the words that we have beat you guys to death with to know that you should be taking derivative of somebody. The first word is slope of the, you got it, tangent line. When you hear those words, the slope of the tangent line, you take the derivative and you actually plug in whatever point x equals they give you, and you get a numerical value. And evaluating a derivative at a point gives you, quote unquote, the slope of the tangent line. So when I hear the word calculate the slope of the tangent line, you know you're going to be taking a derivative. What are some other words? Well, the other words would be, that we used, is the instantaneous rate of change. You hear that word, calculate the instantaneous rate of change of f of x at x equals 3. You're going to take the derivative and plug in x equals 3 into it. Rate of change means take derivative. But then we start getting into lazy mathematician notation. So the idea of instantaneous rate of change, and after a while we just kind of short them. Calculate the rate of something or other after a certain amount of time. That word rate, that's a classic bros word that you need to be taking rid of somebody. Now, we do have the formula for our average rate of change. That's the formula f of x2 minus f of x1 divided by x2 minus x1. But when they just say, calculate the rate of p of x when x equals 2, yeah, take derivative and plug in x equals 2. They're going to shorten it up to be, just call it the rate. But a new one for you guys. Now, you guys are business calculus, so we're focusing on, for the most part, we're focusing on profit, revenue, cost. And when you hear the word marginal, marginal profit, take derivative of profit. Marginal cost, take derivative of the cost function. Marginal revenue, take derivative of revenue function. Marginal means derivative. So for you guys, it's one of the most important concepts to get down. So when you're calculating something or other, and you're working in your business world, and they're talking about marginal rates, that's the derivative of whatever function they're talking about. Marginal profit, they're talking about taking derivative of the profit function, okay? And just to let you guys know, and we've kind of talked about this a little bit, unit analysis. When you hear the word per in terms of units, feet per second, dollars per unit, all these concepts mean derivative. That word per in the unit means it's a derivative. So these are the little technical things you can be paying attention to when you start looking at your information and stuff. Now, let's just review a little bit from chapter 1.8 material, the review of things you're supposed to know. All right, we have X is traditionally in the business world. X is going to be the number of units. Now, depending on what you're talking about, maybe the number of units you sell, the number of units you produce, it's just some kind of number of units that you're playing around with. And P, little p, is denoted typically as the price of said units, and it's equal to D of X, called the demand equation. You have a demand equation, and you also have a supply equation. And we'll call that S of X later on. But typically P, price of said commodity, is equal to D of X. And based on the number of units you guys can produce, we're going to be setting our price. So if we don't produce that many units, typically the price is pretty high. But once we get our mechanisms in order and we start mass producing said units, the more we can produce, the price can go down on this stuff, that supply and demand concept. So, these are your two big concepts. Now, revenue. Formula for revenue, R of X. Symbol for it, typically, big R of X. How do you calculate revenue? It's the amount of money you bring into the company. You take the number of units that you sell, number of units, that would be X, times the price, or that demand equation. They give you a demand equation as such. So this is a formula you guys need to know. X times price, that's a little p there, or you can also write this as X times that D of X demand equation they give you. Okay? Cost, symbol for that is big C of X. Well, the cost A lot of the times, they're going to give you the cost equation. But sometimes, they're going to give you information that you're going to have to come up with. So your cost equation is going to be based upon something called the fixed cost plus what they call the variable cost. You know, for example, all right, only because I have my calculator up here, we produce calculators. Okay? Well, for me, that's just to set up my company on producing said calculator, I'm going to have to, it costs me, $1,000 a month, or let's, to actually produce, just to set up the building. The utilities, to pay my employees, so forth and so on. Those are my fixed costs. I can pretty much bank on this being the same amount every time period or whatever that I'm looking at. So that's my fixed cost. But then we actually have the cost for the unit. In terms of putting this thing together and stuff like that, this thing cost me, let's say, $50 per calculator that we make. And so my cost equation would be that $1,000 fixed cost that I have plus 50 times X, where X is the number of units I produce. $50 per calculator times X, the number of calculators I produce. So I'm going to have to create this cost equation. A lot of the times they give you just, hey, cost equation is 0.02X squared plus 50X plus 5,000, something like that. They'll actually have an equation for that, okay? But when they don't, you'll have to create one. And then the big deal is, what we're all interested in is profit. Now, profit is big P of X, so please pay attention to the size font that we're using on this stuff. When you have a little p, that will be price. When you call a big P, that will be profit. And the formula for profit is revenue minus cost. So P of X is equal to R of X minus C of X. Well, I'm just getting you started in section 2.4, but this is a review of what we did before. Now, we'll be talking about some other forms in here, and we're also going to be talking about some terminology. So this is a lot of terminology in this particular section. So we come over here to our section 2.4 marginal analysis stuff. All right, the big deal is that term marginal. Now, I'm just throwing it right into your face. When you analyze that concept of marginal, you're actually talking about taking derivative, because that marginal units, we're talking about, if I'm talking about a profit, I'm talking about, the marginal profit would be dollars per unit that I produce at that particular level. The revenue is dollars per unit, based upon how much money, how much money's coming in my company. After I sell 50 calculators, I'm going to be making so many dollars per unit of calculator that I have. As X changes, my marginal cost or marginal profit will change. Same idea with marginal cost. Cost is measured in dollars, but when I do the marginal cost, you take derivative of cost with respect to the number of units X you produce, you get dollars per unit, the cost of the dollars per unit at that level, okay? That per means it's a derivative, so marginal means derivative. Now, so in terms of our learn mode, and hopefully you watched the learn mode before you came to class on section 2.4. The marginal cost is represented by what notation? Okay? Well, cost is represented by what? What was my symbol for cost? Big C of X. So marginal means what? C prime of X. It's going to be the derivative of cost. Similarly, the marginal revenue is represented by the notation. Well, revenue is R of X, so marginal revenue is R prime of X. And similarly, marginal profit is denoted as big P prime of X. Okay? All right, so filling out the blanks. So here's a new one here for you. Blank blank is the total cost divided by the number of items X. Now, when you take your, quote, total means add. So when you add up a bunch of things, let's talk about what you guys are most interested in this class, grades. If you add up the number of grades you have and divide by, add up all your grades, you add up all your grades and divide by the number of grades you have, what does it calculate? Your average, okay? It tells you how well you're doing in the class. So similarly, in terms of cost, when I take the total cost, that's basically adding up all the costs divided by the number of items, dividing by the number of items I have, that's going to be the average cost. Does that make sense? I mean, the total divided by, I mean, it's basically, they're trying to put the words for, I take an average, you add up the number and divide by the number of items that you got. That's how you figure out the average. Okay? But this average cost does have a symbol here. So this is a notation that you need to denote, and it's called C with a bar over it of X. And honestly, that comes from statistics. In statistics, we talk about the word mean, M-E-A-N. Mean, for you guys, means the average. You add up the number of pieces of data and you divide by the number of data. And the symbol for that is X bar. But you guys are in business calculus here, so we're talking about cost, so the average cost will be C bar of X, and it's actually equal to that cost function divided by X. So you have to take the cost and divide by X, and that will give you your average cost. Does that make sense? Uh-oh, here we go. Now, what do you think is the notation for putting some words together? The marginal average cost is represented by what notation? What does the word marginal mean to you guys? All right. And we're talking about average cost, so we're talking about C bar with a prime on it of X. It's the derivative of this thing here. All right. Again, terminology here. Consumption functions give an estimate of a country's total annual consumption of consumer goods. The rate of change, was that word rate of change mean to you? Okay. Of such a function is called the blank blank to consume. And that word, when you're talking about a rate of change, you're talking about derivative, it will be the marginal. And the other word is propensity. Propensity. All right, marginal propensity. All right, and there's typically, when it comes to these consumption things here, there's two aspects of it, and we're about to get into that. But the marginal propensity to consume is the derivative of your consumption function. Okay? Marginal means derivative. Marginal propensity to consume. Now, number 8, here we go. More terminology for you guys. Suppose the X represents the total national income. So now we're talking about business on a national level. So suppose X represents the total national income. C of X is the amount of consumption, and S of X is the national savings. Then C of X is equal to S of X, excuse me, C of X plus S of X is equal to X. Let me explain. Whether you're talking about national or you're talking about your local economy in terms of what you have in terms of money in your pocket and what you bring into the home. I make money. Not very much. I work here. But I make some money. And I do two things with my money. I spend it. I have kids and a wife, even more. All right. And what little's left over is I try to save it, right? I'm going to give you guys a reality check here. So with your money, you do two things. You either spend it or you save it. The C is the amount of consumption. You know what that is? You're consuming stuff. What does that mean? You're buying stuff. You're heading to Walmart and you're purchasing a bunch of stuff. You know, the cart and big credit card thing there. Right. But then plus, what's left? Well, the $3 I get to put in my savings account or my piggy bank or whatever you want to call it. But when you put those two concepts together, the consumption plus the savings, that will be equal to the entire income that you have. You're going to do one or two things with it. You're either going to spend it or you're going to put it away and save it. And putting it together, consumption plus savings is equal to X. X represents the total income in this format. So it would follow that when I take the derivative of this here equation, The derivative of your consumption, C of x, would be the C prime of x. This would be the marginal propensity to consume, listen to my words, plus S prime of x, take derivative of S of x, would be S prime of x. That would be the marginal propensity to save. That's just your savings, your marginal, that you take derivative of saving. And that would be equal to what? Well, take derivative of this side, it's got to be equal to derivative of the other side. What's derivative of x? What's derivative of x? 1. It's equal to 1. Don't think too deep in this, but it's the concept of how the rates work up. So if you look at your rate at which you spend plus the rate at which you save, that's going to be equal to 1 because there's only 2 rates you happen to have. So these guys are what we call basically complete opposites in terms of this. So if this was 75% of my money I spend, 25% of my money I would save. I'm sorry, more reality. 97% of the money I spend, 3% of the money I save. The government's not real happy with me right now. Does that make sense? But the total, it's got to be equal to 1 or 100% if you want to think about that. This is the concept here. So again, we're getting into this business aspect of this stuff. Okay? So, hopefully you went to www.hawkstv.com because they have a nice little example right there waiting for you guys to watch. But it's not this example, but it's a similar example. So here we go. Let's do this one right here. Suppose that a manufacturer has determined the price of producing X units of a commodity given by P, which is equal to D of X, equals 117 minus 0.25X. And the total cost is given by C of X equals 225 plus 2X squared. Determine the marginal profit for selling 16 units. It's a word problem. All right. So, first off, all this good information here, what are we supposed to find? So I'm going to show you guys how to use, as a mathematician and a business person, you want to sit there and analyze this stuff. You analyze it from a math perspective. Read the problem again, and then look for what you're trying to find. What am I trying to find on this problem? Well, I've got manufacturer determine the price of selling X units, X is units, and I got P, which is little p, means price, or that demand equation is 117 minus 0.25X. And the total cost is given by C of X equals 225 plus 2X squared. Determine the marginal profit. What does marginal mean? Derivative of profits. The first thing I got to do is find profit. What does profit? Right. Profit, which is big P of X, is going to be R of X revenue minus C of X cost. So I got to come over here and calculate revenue. That's that R of X. What is the formula for calculating R of X? What's your formula for revenue? X times P. X times price, right? And they gave me the price equation. So this is going to be X times 117 minus 0.25X. I'll clean them up later. There it is, okay? And then I need cost. My cost equation, this is called C of X. Well, Merry Christmas. They gave that one to me, so I don't actually have to do anything. That's just 225 plus 2X squared. Does that make sense? Now, let's come up with your profit equation. So your profit is going to be equal to, we call it big P of X here, your revenue, which is X times 117 minus 0.25X, close parentheses, parentheses around your revenue, minus parentheses around the cost. 225 plus 2X squared. Now I'm going to clean this guy up. How do I clean this guy up? So I've got P of X, profit. Here I'm going to distribute the X. So this is going to give me 117X minus 0.25X squared. And here I'm going to distribute the negative, because when you subtract a function, you have to distribute the negative, and then you're going to collect like terms. So this would end up being minus 225 minus 2X squared. Let's combine like terms here. So this means my profit equation is, well, let's see here. I have here, what is negative 0.25x squared? Is that the only x squared I got in here? No, plus 2x squared, here it is. Minus 2x squared. What is negative 0.25x squared minus 2x squared? Well, when you add coefficients, when you add terms, like terms, you just add their coefficients. What is negative 0.25 minus 2? Well, they're the same signs, so add them up, what do you get? I got negative 2.25 x squared. Does that make sense? It doesn't matter what the coefficients are. This is negative 0.25, this is negative 2, minus 0.25, minus 2 is negative 2.25, and they're both x squared. Plus 117x, this term, and then minus 225. All this is just to come up with the equation so I can actually do the problem. Because you're in calculus class, you are not happy until you take a derivative, and you knew you were supposed to take a derivative with the word marginal. Now, let's calculate that marginal profit. So I'm going to come over here. I'm going to talk about the word marginal profit. So that we're looking for P prime of x. What's my marginal profit equation? Well, what is the derivative of negative 2.25x squared? You take the 2 and multiply it by negative 2.25. I'm just going to show you this on the calculator here. Negative 2.25 times 2 is negative 4.5x to the first power, plus, what is the derivative of 117x? 117 minus, what's the derivative of 225? 0, because it's a constant. So there's my guide. But go back and make sure you read the question here. What was the question? Determine the marginal profit for selling 16 units. So we wanted to find the marginal profit when x, which is the number of sales, is equal to 16. So what's my last move? Question. You got it. Plug in 16 into your grid. So P prime of 16 is going to be negative 4.5 times 16 plus 117. And again, I'll put this on the calculator. Negative 4.5 times 16 plus 117 is P prime of 16 is equal to 45. Does that make sense? But one more thing you got to do to get full credit on this problem, because it's a word problem. Something missing. You know what that is? Units. When I give you guys a word problem, you've got to tell me the units. You don't get the full credit on this thing. We found the marginal profit. In terms of units, profit is measured in dollars, but when you take a derivative, what do you get? Per, and what do we take derivative of? With respect to x, and x was what? Units. So the answer is $45 per unit. Now, from a business perspective, please understand this. All right, so in this particular problem, we had our price equation. From that, we multiplied by x, we got revenue. And the minus, they gave us a cost equation. We subtracted it, we cleaned it up. And then we have a profit equation. And then we took the derivative of said profit equation. And we plugged in 16. And when I did this, I got $45 per unit. So what does this actually mean? This means, in my company, at the point that I am selling 16 whatever items, whatever I'm selling, and once I've sold 16 items, I am actually making $45 per item in terms of profit for the company. Does that make sense? And as we sell more, sometimes this marginal profit will go up, sometimes it goes down. I mean, you have to, that supply and demand is all based upon these equations and stuff like this. So, but right now, what this is telling me is once I sell 16 units, I am actually making $45 per unit in profit for the company. Does that make sense? All right? Let's take a look at some of these practice problems here. Okay. A vendor charges P of X, and that's a little p, by the way, equals 22.5 plus 0.5x for a certain commodity. What is the revenue function? All right, that's a little p, and they talk about vendor charges. So charge means this is a price. So again, you have to create these formulas, because if I can't get you guys to create the formulas, all this wonderful stuff on taking derivatives is out the window, because if you can't create the formula, the equation, what's there to take a derivative of? So you gotta master this. So revenue equals R of X, but the formula for that is X times P, X times price, or X times your demand equation. So this is gonna be X times 22.5 plus 0.5X. And I'm gonna clean that up, so I get the revenue equation being equal to 22.5X plus 0.5X squared. Does that make sense? Now, they didn't ask me to find the marginal revenue. If they did, not a problem. I take derivative of it. R prime of X would be 22.5 plus 2 times 0.5 is 1X. And then I can plug in number they want me to do in that. Look at number 2. It says a supplier of T-shirts charges vendors for each order based upon a set of a fee of $50 and then an item charge of $1.15 per T-shirt. What is the cost to the vendor? So this is classic. All right. So I'm going to place an order with some company. I have this setup fee. For me to just even place the order to get the process and for them to get the design that I want and all this other stuff, they're going to charge me $50. Then they're going to charge me an additional $1.15 per, in this case, T-shirts. So what is going to be my cost function? Cost, big C of X, would be equal to what? Well, you have, this is the idea of that fixed cost plus the variable cost. Fixed cost plus variable cost. What is your fixed cost? What are they charging you? $50. Plus, what is my variable cost? My variable cost is $1.15 per T-shirt. So I got to multiply by X, where X is the number of T-shirts. Does that make sense? So the answer to the question is C of X is equal to 50 plus 1.15x. And just to keep practicing, if I was told, calculate your marginal cost, what would that answer for the word marginal cost be? It doesn't matter how many units you produce, marginal cost. It'll be derivative 50 is 0, derivative 1.15x is 1.15. The answer is 1.15 would be the marginal cost. Does that make sense? Next. The owner of a leather craft shop has determined that he can sell X purses if the price is P of X, which is your demand, D of X, equals 46 plus 0.25X dollars. Okay? The total cost for these purses is C of X equals 0.15X squared plus 6X plus $190. Find the marginal profit function. It's time to ask for the marginal profit function. Before I can find the marginal profit function, I got to find the profit function. So to find the profit is equal to revenue minus cost. Revenue minus cost. So I first got to come up here with revenue. What's my revenue equation? R of X. What's that equal to? X times P. That's going to be X times 46 plus 0.25X. And so there's my revenue equation. I'll clean them up later. The cost equation, that's awfully nice of them. The cost equation, they gave it to me. Big C of X was 0.15X squared plus 6X plus $190. So I don't have to do anything to come up with the cost. They gave that one to me. So to get what I'm after, my profit equation will be equal to the revenue equation, which is X times 46 plus 0.25X minus, parentheses around anything you subtract, your cost equation. 0.15X squared plus 6X plus 190. But before I do any kind of derivative to get that marginal, you got to clean this thing up. So that means my profit equation is going to be equal to, but I'm going to distribute the x here. That gives me 46x plus 0.25x squared. Now I'm going to distribute the negative. That'll be minus 0.15x squared minus 6x minus 190. So I end up getting the profit equation being equal to, and now I'm going to combine like terms. Now, you notice these are traditional polynomials, so when I like to combine like terms, I like to go in decreasing order of the powers, so I can get the degree type thing here. So I'm looking at the highest power sees x squared, so I've got 0.25x squared minus 0.15x squared. What is 0.25x squared minus 0.15x squared? 0.1x squared. 25 minus 15 is 10. This is cents, that would be 0.1x squared. Combining x's, I got a 46x minus a 6x. 46x minus 6x is plus 40x. And then I got one constant minus 109. Does that make sense? But now, to answer their question, the word is marginal profit. So we're looking for this marginal profit. Just get you the words here. Marginal profit is P, big P prime of x. So, take derivative. What is the derivative of 0.1x squared? I'm going to calculate for this. When you take derivative of x squared, you bring down the 2, and 2 times 0.1 is how much? 0.2x. Subtract 1 x squared, subtract 1 gives you just x. Plus, derivative of 40x is just 40. And derivative of minus 190 is 0, so this is that marginal profit equation. Does that make sense? And then they can, part 27 on any kind of test question I give you, let's calculate the marginal profit when x equals 50. Plug in x equals 50, crank out a number, and it'll be dollars per unit would be what your answer is. In this case, dollar per purses, because we know what the units they're selling here is purses. Does that make sense? All right. All right, so let's see if we can mess you up a little bit more in terms of wording. Pay attention to the wording. So here it is. The total cost of producing X clock radios is given by the function C of X equals 300 plus 24X minus 0.4X squared plus 0.1X cubed. Find the marginal average cost if X equals 4. Okay? All right. Before I can find the marginal average cost, I got to find the average cost. Because we know the word marginal means derivative. So the first thing I'm going to try to find is average cost. And we got a formula for that. Remember, average cost, so yes, there's a lot of stuff you have to memorize for this class, is denoted as C with a bar over it of X. And the formula is their cost equation divided by X. This is what we were discussing before. Your average cost. And since this C of X is actually your total cost, okay? So this would be equal to, okay, this is your cost. This is going to be 300 plus 24x minus 0.4x squared plus 0.1x cubed divided by x. But I'm actually after, that's good to go with the average cost equation, but I'm after the marginal, which means I need to take derivative of this guy, which means before I can take a derivative, I've got to clean this guy up. Since we are dividing by a single term, I'm going to take that single term and put it under each term in the numerator, and then clean that up. So this would be equal to 300 over x plus 24x over x minus 0.4x squared over x plus 0.1x cubed over x. So your average cost equation, when you clean them up, there's nothing to clean them up when you got 300 divided by x, so that's just 300, but I can clean them up a little bit because I'm going to take a derivative. So when I divide by x, I can bring them to the top and it becomes x to the negative 1. So this is 300x to the negative 1. When you bring things to the top, make the exponent negative. Now here, this one is 24x divided by x. What happens to the x's? they're going to cancel. So that ends up being plus 24. This is minus 0.4, but it's x squared divided by x. What is x squared divided by x? Well, x cancels with one of the x squared, so you're left with 0.4x. And last is plus 0.1 x cubed divided by x. What is x cubed divided by x? X squared. So one of those guys are canceled, but they're still left with 2 left over. So this is your average cost equation. So now we want to figure out what the marginal average cost is going to be. What's marginal mean? Derivative. So this will be c bar prime of x. So let's take the derivative. What's the derivative of 300x to negative 1? Bring down your power. Negative 1 times 300 is negative 300x, and subtract 1, negative 2. Plus, what's the derivative of 24? This is for your benefit. 0. Minus, what's the derivative of 0.4x? 0.4 plus, what's the derivative of 0.1 x squared? 2 times 0.1 is 0.2x. Does that make sense? Derivative of x squared is 2x. 2 times 0.1 is 0.2x. I'm going to clean this guy up just to make him look good. So c bar prime of x, the marginal average cost equation, and negative exponent goes back where they came from. This will be negative 300 over x squared minus 0.4 plus 0.2x. But make sure you always answer their question. What was their question? We're supposed to find the marginal average cost if x equals 4. What does that mean? I'm looking for. Plug in 4. I'm looking for c bar prime of 4. This would be negative 300 divided by 4 squared minus 0.4 plus 0.2 times 4. Yep, and I'm going to put that on the old calculator here. Okay, this would be negative 300 divided by 4 squared minus 0.4 plus 0.2 times 4. And I get negative 18.35. And on Hawks, when they ask you a question like this, you're just supposed to plug in the numbers. Don't put in the new units. But if I give a problem like this on a test or something or other, being a word problem and all, I do expect units. Now the question is, what would the units be actually on this thing? All right, hang with me here. So, average cost is cost per unit. That's what the units are for an average cost. It's your average cost per unit. And cost is measured in what? Dollars. We're Americans, dollars, of course. So it's dollars per unit, but then you took the derivative of that. And when you take a derivative, what are you going to do? Per unit. So you get actually per unit on this thing. So this is actually dollars per unit per unit. Dollars per unit squared if you want to go that route on it. But this would be the units on this thing. Because your average cost is dollars per unit, but then you took its derivative with respect to units. So it's dollars per unit per unit. Does that make sense? Not difficult, but more hoops to jump through is more than anything on this problem. And you have to know formulas. Look at the last one. Okay? It says this. Suppose that the total national consumption, all right, here we go. Suppose the total national consumption is given by a function c of x equals 200 minus 0.6x minus 0.05x to the 0.6, where x is the total national income, okay, consumption here. Determine the marginal propensity to save. All right. So this part goes back to part of that formula. You remember this one here? It was this. Consumption plus savings was equal to what? You remember the formula? Consumption plus savings is equal to X, income. This was a formula. Please refer back to, hold on, I got it right over here. It's this formula right here. Consumption to save, I mean, consumption, that's basically consumption, that's what you're purchasing, plus savings is equal to X. Okay? So here we go. Now, I know the cost, that is 200 minus 0.6x minus 0.05x to the 0.6, plus your saving is equal to x. Now, what do they want me to find? We're supposed to find the marginal propensity to save. Save, that's your key word right there, is your S of x. And this marginal propensity means what? You got it. Marginal propensity to save. Marginal propensity is this idea of just the derivative, but to save would be S of x would actually be S prime of x. So I want to find S prime of x on this one. So let me show you what I'm first going to do is going to solve for S of x. To solve for S of x, I'm going to add 0.05x to the 0.6 here. So I'm going to add 0.05x to the 0.6. I'm going to add 0.6x to both sides, add 0.6x, and I'm going to subtract 200. I'm moving all my other terms to the other side. This cancels, this cancels, this cancels. That gives me S of x equaling, now we need to combine my terms. So here it is. Please help me out here. What is x plus 0.6x? How much? All right, they're both x's. You just add their coefficients. This is understood to be 1. 1x plus 0.6x is how much? 1.6x. Plus the other parts, 0.05x to the 0.6 minus 200. But what we're after on this thing in this idea of marginal propensity to save is going to be S prime of x. So what is the derivative of 1.6x? 1.6. Oh, here it comes. Plus, what is the derivative of 0.05x to the 0.6? How do you take a derivative of this thing? You bring down your 0.6, and 0.6 times 0.05 is 0.03. X to the what? Subtract 1 from the exponent. What is 0.6 minus 1? Negative 0.4. And the derivative of minus 200 is what? 0. And this is the formula for the marginal propensity to save, S prime of x, in this classic formula. Does this make sense? So you begin to see the kind of hoops you guys are going to jump through, and then we're going to evaluate this type of stuff. So study hard on this one. Don't forget your homework and stuff like that. Oh, one last thing I want you guys to pay attention to while you're here. Hold on. And that is this over here. This is your schedule in terms of things and how we're covering stuff. We just finished up section 2.4, so pay attention. We got a test coming. We got one more section to cover before our test. So look at your dates. We're good to go because we're actually on schedule in here. So study hard, and I'll see you guys on Monday.